Hello. This video is to help explain exactly the effect that this a value will have for a quadratic function, for an absolute value function, and for an exponential function. That a value, that number in front of the function. So let's start with this blue one over here, something we've seen. And we'll do an XY chart for that real quick. Y equals x squared, the parent function for the quadratic function or quadratic family of functions. So we've got y equals x squared, so negative 2 squared. Negative 2 times negative 2 is 4. Same thing for negative 1 is 1. 0 squared is 0. 1 squared, that's a little bit easier without the negative. There's our XY chart there. Now, if we do that same thing, go through that same process over here, order of operations, we're going to have to do, remember this is a little negative 1 right here. So it's negative 1 times negative 2 squared. So negative 2 squared is 4, and 4 times negative 1, negative 4. Negative 1 times, this one will plug in negative 1 squared. Square it, becomes positive 1 times negative 1 is negative 1. 0, negative 1 times 0 squared, we'll check that one. 0 squared is 0 times negative 1, 0. So that's the same. Remember, this is the vertex over here. This is the vertex of the parent function. Same vertex for this one, with an a value being the only transformation, only change. So now 1, so negative 1 times 1 squared. 1 squared is 1 times negative 1. Because we do exponents before multiplication again, we get negative 1. Negative 1 times 2 squared. 4 times negative 1, negative 4. So there we go. There is the XY chart for these. Now, if we did graph that, we could easily plot those points on a graph. This is what it would look like. And I'm going to just switch these so you can see what happens when we do it. I'm going to plot those same points we just had. We've got this one was negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. We've got something that looks kind of like this. Goes on forever. And then the other one was negative 2, negative 4. Negative 1, negative 1, 0, 0. That's that vertex again. 1, negative 1, and 2, negative 4. So here we go. It's rounded. Exact same graph, just upside down. There's our graph. One other way to look at it is like this. I've got a graph right here. Take this same one. So this is pretty close. It keeps bending on me, but that's that same graph there as it would be here. Exact same curve, exact same shape, except the negative, what did it do? It just flipped it upside down. That's all it did. Let's take a look also at a graph that has been moved a little bit. So if we look at this one, x, y equals 2 times x minus 3 squared, and y equals negative 2 times x minus 3 squared. So that minus 3 is going to shift it, either left or the right. Do you remember which one? You got it, I think. To the right, 3. That's all. It's in with the x, so it's going to move in the x direction, but it shifted the right 3. But that 2 makes it, instead of being our graph we had before, it makes it a little bit more narrow. A little more narrow because it stretches the graph vertically. So instead of being wider like it was before, it's going to be more narrow. So there we go. We got that one. Now the negative 2 in front is going to keep that vertex in the same spot. It's still shifted 3 to the right. It's still a quadratic function, still the same parent function, but here's what it did. It flipped it. It flipped it, still just as narrow as it was, exact same function, exact same width, but now it opens downward instead of upward. Downward instead of upward. That's the only change there. Let's take a look at one that is, let's go to an absolute value function. Let's look at this one. See what this one looks like on the graph. We've got a shift going on here again. Now let's think of the vertex. The vertex was, let me use this little thing to point. The vertex was moved over to the left 2 and down 4. So 1, 2, 1, 2, 3, 4. There's our vertex. So let's put our graph on there. Vertex right there. There we go. And there's our vertex. And our app, oh boy, lost it. -2, -4. There we go, pretty close. There's our graph of the absolute value function. But now, remember, it's flipped now. That negative, only thing changes the negative a value. It's going to take that same graph, and now it's going to open downward. There's the change. Oh, it's off the, there we go. Same graph, same vertex. It just opens downward now instead of upward. And you may guess what it's going to do to our exponential function. Let me get this one in the right spot here. In the exponential function, there we go. We got 4, 8, about like that, with an asymptote. Now our asymptote is the x-axis. Let me just get a new one to put on here for you. Asymptote is the x-axis, and so we're going to look at it flipping. Remember, it's going to take that y value and just multiply by -1. If we change this, instead of being this function, y equals 2 to the x, we're going to make it, oh, that glare, there we go. We're going to make it y equals -2 to the x. Remember, it's 2 to the x times -1, so it's really this in disguise, -1 times 2 to the x. That makes sense, but we're going to write it this way. So should be the same graph, just flipped now. So here we go. It's flipping over the x-axis because it's going from positive y value to negative y value, and it's going to change some things, but some things stay the same. The asymptote will stay the same. Let me say that again. The asymptote will stay the same. The asymptote is still the x-axis, but now the graph goes down. It's decreasing as we go left to right. Same graph. The a value has just flipped it. That's the effect the a value has when it changes from positive to negative on the parent functions for a quadratic function, absolute value function, and exponential function.